Okay, this is the start of the back of the 3D test review sheet. Okay, this is starting on number 4. It says find the slant height, x, of the pyramid shown to the nearest tenth. Slant height. Well, first we need to think, well, what kind of equation uses slant height, or L, of a pyramid? If we take a look at the formula chart, we can notice that we could either use um, one of a couple different things. But there's a couple formulas that do use them. So there's lateral surface area that uses slant height. Okay, there's total surface area that uses slant height. And if we look at volume, volume does not use total surface area. Okay. Now these are the two things that we could use slant height for. Okay, but that's not quite what it's asking us. Instead, it's just asking us, let's find this number. Okay, well, we need to look, first we need to know, yes, this is a pyramid. Okay, so on this pyramid, we know that this is a square pyramid because the base, both of the sides are 3, meaning this would be 3 over on the left side, and the back would also be 3. And we also know that if it's a square or a rectangle, we can split the side in half, so 3 divided by 2, which would be 1.5 as a fraction, or as a decimal, and we can draw this down here. We would call that 1.5. So now we have a little right triangle drawn. And if we have a right triangle, you can use 2 of the sides of a right triangle to find the third by Pythagorean theorem. So we can say 1.5 squared plus 4 squared is equal to x squared, and this x being our slant height. So 1.5 squared gives us 2.25. 4 squared gives us 16, and x squared. Now we can add these two things together, 16 plus 2.25, and we get 18.25 is equal to x squared. To get rid of the squared, coming up here, to get rid of the squared, you say x is equal to square root of 18.25. Now I don't know about you, but I don't know this one off the top of my head, so I'm going to have to put this one in the calculator. So square root of 18.25, and we end up getting 4.27. It says up at the top, round to the nearest tenth. So that this is a tenths place, 1 decimal. So we look at the next number, 7, tells us to round up, meaning 4.3. And that would be our slant height. Next question, it says find the height of the cylinder. Well, in this case, it actually tells us the volume right here. It says the volume is 271.4 inches cubed. Well, why does it tell us the volume? It tells us the volume because we know that the volume of a cylinder is big B times h. Now, why do we care? Because h is what we're looking for. I have the radius, so that can help me find the area of the base, and I already know the volume, so it'll help me cancel out everything to find height by itself. So let's go ahead and do that. So volume I already know, so I'm going to go ahead and plug that in. So volume is 271.4, and that's equal to big B times h. Well, remember, big B is pi r squared. Why? Because big B stands for the area of the base, and the base is a circle. The area of a circle is pi r squared. We know the radius of this base, the circle, is 6. So 6 squared is 36. We get 36 pi. I'm actually going to go ahead and multiply these together. So 36 times pi gives us 113.09, round to the tenths, 0.1. So now we can plug that in for big B. 113, put this in parentheses, 0.1, times the height. So now the only thing that we don't know is the height. How would you find the height? Well, this is just regular algebra. So to get rid of this, 113.1 is being multiplied by h, so we divide by 113.1. We do the opposite. Whatever we do on one side, we have to do on the other. These cancel. We end up getting height is equal to, well, whatever 271.4 is, divided by 113.1. we end up getting 2.4. Okay, and that would be our height. If we're looking at units, this would be, since everything is in inches, this would also be in inches. Next problem. This one says, number 6, it says the radius of the base of a cylinder is 28 centimeters, and the height is 48 centimeters. Find the surface area of the cylinder in terms of pi. Okay, so surface area of a cylinder is going to be, and by the way, this is asking for total surface area. It'll ask us for lateral surface area. If it's asking for lateral surface area, it'll tell us specifically lateral. So this is asking for total surface area, so we want 2 pi RH plus 2 pi r squared. This is the total surface area for a cylinder. Okay, so let's start plugging some numbers in. We got 2 pi radius. It tells us the radius of the base of the cylinder is 28. The height is 48 plus 2 pi, again radius, 28 squared. Okay, so on the left side of this plus sign, I'm going to do all of this stuff first. So 2 times 28 times 48, and we end up getting 2,688 pi. Leave in terms of pi, meaning multiply only the numbers, not pi, plus 28 squared is 784. I'm going to write that up here. 28 squared is 784. Then we're going to multiply these two numbers with 2 and 784. So 2 times 784, and we get 1,568 pi, again leaving in terms of pi. Now we can just add these two numbers together. So 2,688 plus 1,568, we get 4,256 pi. And that is our total surface area, pi. Now, thinking about this, since it's area, what would be our units? Well, the units is centimeters, and area tells us squared. So centimeters squared. Number 7 says find the surface area of a conical grain storage tank. Conical. That's an interesting word. Conical meaning cone. Grain storage tank that has a height of 39 meters, a diameter of 14 meters, and a slant height of 40 meters. Round the answer to the nearest square meter. Okay, so we want to find total surface area of a cone. Well, the total surface area of a cone is pi r L plus pi r squared. So let's start plugging some numbers in. Pi, radius is, well, the diameter it says is 14, so the radius, diameter is 14, so the radius we divide by 2, so we get 7. Slant height is 40 plus pi, radius again is 7 squared. Now there's a number that we didn't actually put into this formula, and that says the height of 39. Well, on surface area of a cone, we don't actually need the height. We don't care about the height. It's not part of our equation. So this is actually extra information here to throw you off. Okay, so let's go ahead and multiply these out. 7 times 40 is 280 pi, plus 7 squared is 49, and carry along that pi. 280 plus 49, and we get 329 pi. Now this is in terms of pi, which is an okay answer if that's what it's asking us for, but in this case it says round the answer to the nearest square meter. So it's wanting us to go ahead and multiply these together. So I'm going to go ahead and do that. If we multiply 329 times pi, we get 1,033.58 square meter, Round to the nearest square meter means whole number. So we don't want any of these decimals. So we look at the first decimal number, 5 means round up. So we get 1,034. Next question, number 8. Says the volume of a sphere is 4,000 pi. Go ahead and underline that. What's the surface area of the sphere to the nearest square meter? It gives us volume. But how do I take volume to find surface area? Because the surface area equation of a sphere is 4 pi r squared. This has nothing to do with what our volume is. So what do I need to do? Well, what I need to do is I need to know that the volume equation for a sphere is 4/3 pi r cubed. And why would I write this down? I'm not trying to find volume. I already know volume. Well, I can use this to plug in my 4,000 pi for volume. And I can use this to solve for radius. And if I find radius, I can plug in radius into my surface area equation, and that'll give me total surface area. So first thing I'm going to do is, if I want r by itself, radius by itself, I need to get rid of all these other numbers. So I'm going to get rid of pi first. If I divide by pi on this side, it cancels that out, but I have to do it on this side also. So these pi's cancel out. So I'm left with 4,000 on the left side and 4/3 radius cubed on the right side. Next thing I'm going to do is divide by the fraction 4/3. So these cancel. We get 4,000 divided by 4/3. And I know that's a little weird to do if you're dividing by that fraction. But if you do that, you end up with, I'm going to go up here, you get 3,000 on the left side is equal to just r cubed on the right side because the fraction now is canceled out. Interesting. To get rid of the cubed, we got to remember to do the cube root. The cube root of cubed, those cancel out, and we're left with r on the left side. And the cube root of 3,000, we probably don't have that memorized either. And we end up getting 14.42 as our radius. Okay, so I'm going to go ahead and plug this number in. So let's do it in blue. So 4 pi, radius is 14.42. I went ahead and rounded it to 2 decimal places, just so to give us a little extra breathing room. At the end, we will round to the nearest square meter. Okay, so 4 times pi times 14.42. So I'm going to multiply the numbers first. So 4 times 14.42 gives us 57.68 pi. We're going to go ahead and multiply the pi in there also. So 57.68 times pi. And that'll give us 181.207. So this says near square meter, which is whole number. So we're going to look at the first decimal place. And 2 tells us to round down or keep it the same. So we end up with 181. And that is our total surface area. Units on this case would be meters. Meters, they'd be squared for area. The next question, the volume of a cylinder is 980 pi cubic, or cu, cubic inches. The height of the cylinder is 20 inches. What's the radius? So we're going to use the equation for volume of a cylinder, which is big B times h. And remember, big B stands for area of the base. Area of the base, well, the base is a cylinder. Or the whole shape is a cylinder, so the base is a circle. Area of a circle is pi r squared. So this is our base, pi r squared times the height. But again, we already know what volume is, so we're going to plug this in, 980 pi. We know what the height is. The height is 20. We're looking for the radius. So we don't know r, but we know height to be 20. So first thing I'm going to do is divide by pi on both sides. So these cancel out and these cancel out. We're left with 980 It doesn't look very good. Let's try it again. 980 is equal to r squared times 20. Well, 20 is being multiplied, so to get rid of it, you do the opposite. You divide. So these cancel. 980 divided by 20 gives us 49 equals r squared. Well, we don't want r squared. We want r. We want radius by itself. So to get rid of squared, you take the square root. So we have r is equal to square root of 49. Coming up here now. So radius is square root of 49 is 7. That's going to be our radius. This is in inches, so radius is inches, 7 inches. Next question. This is number 10. It says concrete can be purchased by the cubic yard. How much will it cost to pour a slab 17 feet by 17 feet by 3 inches for a patio? The concrete costs $56 per cubic yard. This is actually a very interesting question. Okay, first thing that we need to do is realize, what is this? So if concrete is being poured, most of the time, especially if it's a concrete slab for a patio, is going to be a rectangular prism. So I'm going to go ahead and try to draw this rectangular prism. It looks something like this. I know it's not the best picture, but what does each of these numbers mean? Meaning 17 length, 17 width, and 3 for the height. But these all have different units. 17 feet, and then this is 3 inches. We can't use all different units here though. We got to make it all the same. I'm actually going to turn all the units into yard because that's what the concrete's cost is in. It's in per cubic yard. So I want everything in yards. So I'm going to try to draw this again, and I'm going to change everything into yards. Okay, I'm not changing the numbers, I'm just changing the units. So 17 feet in yards. Well, how many feet are in a yard? We have 3 feet per 1 yard. So all you have to do is say 17 divided by 3, and we get 5.7. I'm going to go ahead and round yards here. This would also be 5.7 yards because it's also 17. And then this is 3 inches. So I don't only have to turn inches into feet, but then feet into yards. So 3 inches is the same thing as, well, there's 12 inches in a foot. So we say 3 divided by 12, and we get 0.25 feet. Okay, because we divided by 12. We're going to divide this by 3 feet to get 0.25 divided by 3. I'm going to go ahead and use this as a fraction. This is 1 over 12 yards. Why did I choose to use it as a fraction? I chose to use it as a fraction because it's 0.08333333, which is kind of a ridiculous number. Technically, I guess we should use 5.7 as a fraction also. So I'm going to go ahead and turn it into a fraction. This would be 57 over 10. Okay, so this is going to get a little crazy. Okay, so all of this stuff is to find the correct units, and this is all again in yards. Now that everything is in yards, I can now find the volume and then multiply it by the cost to find how much the whole thing is going to cost to make. So now we have it all in yards. I'm going to say, well, how do you find the volume of this shape? And why would we find volume? Well, because concrete being poured is going to fill up all of the space on the inside, right? Not just the outside, and not just one length or something. It's the entire thing on the inside. So that's why it's volume. So we're going to say volume of a rectangular prism being length times width times height. So we're going to say it's 1/12 times 57 over 10 times 57 over 10. If we do all of that, I know it's kind of crazy. 1 over 12 times 57 over 10 times 57 over 10. We get kind of a crazy number as 2.7075. I went ahead and wrote down the entire number, the whole decimal. I could put this in a fraction, but the fraction is pretty ridiculous. So we're going to go ahead and use the decimal here. That's fine. So this is how many cubic yards of concrete that we need. But each cubic yard costs $56. So what we're going to do is now take this total and multiply that by $56, and this will give us the total price. So 2.7075 times $56 per cubic yard, we get 151.62, and this is dollars. So $161.62, or $161.62. Next question. This is number 11. There's two things that we need to do. Part A says draw the net, and then part B says use the net to find the surface area. Okay, so part A, I'm going to do part A up here. Part A, draw the net. Well, this is a rectangular prism. So first, I'm going to draw all the rectangles around, not including the bases. So the first thing is I'm going to draw the top. Looks something like this. Then connected to the top is the side. The side is a little bit skinnier, so something like that maybe. Then we have the bottom, which should be the exact same size as the top. Then connected to that is the back side, which is again a little bit skinnier. I know it's not the best drawing, but it's okay. Then we have these two bases on the side, or I'm going to call them bases on the side. So this right side, this one over here, needs to be somewhere on the right side over here. Well, where should I put it? Should it be up on the first, the second, the third, or the fourth? It actually does not matter, but we need to draw accordingly. So I'm going to put it on this part right here. This would be that base. I'm going to do the exact same thing on the other side. That would be the left side base over here. Now we're going to label each piece. So this number is 10. Well, that's 10 for all of these pieces. We don't need to write 10 for all of them. You only really need to write it for one of them because it'll all be the same. But I went ahead and did it anyways. The skinnier pieces on the side are all 2. So this one's a skinnier piece, 2 and 2. This is 2 and 2. Also, since this connects with this base, this is also 2 and this is 2. This is 2 and this is 2. Then we have this piece right here, which is the bigger part, which is the top and the bottom. That's 6. 6, 6, 6, 6, and 6. Okay, so now that's every single piece labeled. So that would be our net. The next piece of this is to find the surface area of this prism. Well, we could use the net to just find the area of each piece, and that's what it's technically asking us to do, or we can use the equation. Since we've done the equation earlier on the front side of the page, I'm going to actually use each piece. So how do I do this? Well, this is a rectangle, the top part, so I'm going to say 6 times 10, which is 60. This is another rectangle, 2 times 10, which is 20. This is a rectangle just like the top, 6 times 10 is 60. And this is another rectangle just like this one, 2 times 10 is 20. Then we also have these side sections, so 6 times 2 is 12. This is also 6 times 2 is 12. We're going to add up all of these pieces together. We get 60 plus 20 plus 60 plus 20 plus 12 plus 12. You add them all up together, you get 184. You could, to check yourself, take the equation for surface area for a prism, total surface area, which is pH plus 2 big B. You could plug in the answers or the numbers in here and see if you get 184, which you should. Next one, the second part of number 11 is another shape, and this is to draw the net again, and then also use the net to find the surface area. Okay, so this time we have 3 rectangles, which is the front, this big rectangle. I'm going to draw that one first. Outline it right here. Or attempt to outline it. Oh, that's pretty terrible. Let's try again. A little better. Okay, so that rectangle, it looks right here. It's quite large. going to go ahead and label the numbers on it immediately. So this one is 10. This is also 10. This is 17. 17, and this one's also 17. Okay, the next piece, I'm going to also do this in blue, is the underside, the bottom of it, which is another rectangle. I'm going to draw it right here. It's just a little bit smaller than this one. These front and back are also still 17, but this side is now 8. Okay, then the last part, which is the back, is another slightly smaller rectangle. This being 17, and up and down this is 6, and this is 6. So now we have the 3 rectangles of this. Next we want to find the sides, or what we call the bases. So let's do this. I'm going to actually do this in green. Okay, this is the right side, the right triangle over here. So how do we draw this? Well, this is the longest side. I'm going to go ahead and connect it to the longest side. Okay, so it's a triangle. It is actually a right triangle here, so we're going to draw a right triangle. So this goes 6 out like that, and it cuts back in. That's actually not correct. Let me redo that. There we go. So it actually, because this is the hypotenuse, the 10, so it should curve in a little bit like that, where this is the right angle. This is the bigger side, which is 8, and this is a smaller side, which is 6. And it should be the exact same thing on the other side, so curving in a little bit and going out where this is a right angle, this is 8, and this is 6. Okay, so how do we find the total surface area now for B? Well, this is part B. You have to find the area of each rectangle, then find the area of each triangle. So I'm going to do the triangle first. It's base times height divided by 2. The base, we'll call it 8. The height up and down right here, which is 6. I understand it's a little tilted. You might have to turn your head a little bit to see that. You divide that by 2. 8 times 6 is 48. 48 divided by 2 is 24. So this one is 24. Similarly, on the other side, this is also 24. Then we have 3 rectangles. The base being 17, the height being 10, so 17 times 10 is 170. Then the middle triangle, this is base 17, height 8. 17 times 8 is 136. Then the smallest triangle, base 17, height 6, area 102. So we're going to add all those numbers up. So we have 24 plus 24 for the 2 triangles, 170 for the big triangle, 136 for the middle triangle, and 102 for the smallest triangle. 24 plus 24 plus 170 plus 136 plus 102, we end up getting a total surface area of 456. The units are meters, and this is squared. So this actually does take a little bit longer than using the formula for surface area. Just to remember, the total surface area for a prism is P times H plus 2B. This is why we use the formula, to help speed this process up, but it will give you the exact same answer. Okay, the next question, this is number 12. It says a cone that is similar to another has a radius that is 3 times longer. Radius has been multiplied by 3 than the other. How much more surface area does the cone have? How much more volume? Okay, so what we need to do is, I'm going to start with volume. Okay, so we want to know how much bigger is the volume. All we want to know is how many times bigger. So volume, so what do we do? Well, for the volume of a cone, it's 1/3 big B times H. And big B, again, since it's a cone, it's this circle, base is a circle, so the area is pi r squared times the height. So if we notice, r is actually r squared, which is the same thing as writing 1/3 pi times r times h. So we actually have two radiuses in here. So if the radius is 3 times larger, we're going to multiply it by not only 3 for this radius, but 3 for this radius also. So it's 3 times 3, which is 9 times bigger. And that's going to be our answer. So what did we do? We said, since it's 3 times bigger, we said 3 times 3. Again, why? Because we have two radiuses in our volume equation. So our volume is going to be 9 times larger. Okay, next one, 13. It says an oatmeal canister contains 24 ounces of dry oatmeal. A similar, larger version of the canister is twice as tall. How many ounces of oatmeal will it contain? Okay, well, this is an oatmeal canister. Most oatmeal canisters are a cylinder, so we're going to pretend that this one is also a cylinder. I'm going to add that little extra thing. This is a cylinder also. Okay, so it says a cylinder contains 24 ounces of dry oatmeal. A similar, larger version is twice as tall, meaning the height has been multiplied by 2. So how many ounces of oatmeal will it contain? Okay, well, since it's a cylinder, the volume of a cylinder, because this is containing oatmeal on the inside, volume of a cylinder is big B times H. Big B, area of the base, well, since it's a cylinder, the base is a circle, so we're going to say pi r squared for big B, area of a circle, times the height. Take a look at how we notice that height is changing by 2. The radius is staying the same. So what we're doing here is multiplying the height by 2, or I'm going to actually multiply this out. So we say pi radius squared. This is now 2 times the height h. So this is multiplying, so I can take the height, put it out in front. So this is 2 pi r squared times h, meaning the volume multiplied by 2. So how many ounces of oatmeal will it contain? Well, it'll contain twice as more, 2 times more. Okay, well, if the original was 24, we just multiply that by 2, and we get 48 ounces of oatmeal. Next question, number 14. I do believe this is the last one. It says a small box has a volume of 200 centimeters cubed. A larger box is twice as long, twice as wide, and 3 times as tall. What's the volume of the larger box? So what's happening here? So the length has been multiplied by 2, twice as long. The width has been multiplied by 2, twice as long. And the height, height, has been multiplied by 3 times as tall. Okay, so we can find the new volume by using these and saying, well, if the length is twice as big, the width is twice as big, and the height is 3 times as big, multiply each multiplier. So 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. So the volume has to be 12 times larger. The original volume is 200. Multiply that by 12. And we get 12 times 200 is 2,400. And this would be centimeters cubed. This is our new volume. Okay, so this is the end of the test review. This is the back side. If you want the front side, you can look at the other video. Good luck on your tests.